Alright, in this video we are going to go over our test that we just took, our unit test. And what I wanted to tell you was that this is your homework assignment to go through all of these problems, make sure you got them correct, and any that you missed, you're going to go ahead and note that on the form that I've attached to your test. And it looks just like this. Now notice on this, it does say math makeup. You'll put your name, date, and the period. And what I want you to do is to write the question that you got wrong. So for instance, if you missed question number 1, you'll write question number 1, and then you'll write, what did I get wrong? So I want you to, that's a question you should ask yourself. What did you get wrong? For instance, if on problem number 1, you didn't know how to set up your proportion and determine the total change in y over the total change in x. So then you would just say, what did I get wrong? I didn't set up the proportions for my change. Remember, delta y means your change in y over the change in x. So you're just going to write me some statement. Nothing, no answer is going to be wrong. You're just writing to me and letting me know and reflecting on it yourself. What did you do wrong? Because I want to see that you understand what mistake you made. Then, how did you fix it? Well, I'm going to work out these problems, and I want you to see how I worked them out. And then I want you to reflect on that and then make a statement about how you would fix it according to what you've seen done right in the videos that I'm making. Alright, so now that we've gone over that, let's go over our test. So let's take a look at question number 1. Question number 1 says, triangle JNL, and I'm going to highlight these, JNL, and triangles KML are similar right triangles. So let's take a look at our triangles. What I want to do first, and what I think you should always do, is highlight your triangles. So here's JNL. That way we know which one's which. And then KML is going to be the smaller one. And I know the letters are a little hard to see. And we did talk to them at a meeting this Tuesday about the these graphs and making sure that we can see them. And they're going to do a better job the next time around. Just so y'all do know, they do care. And they're trying to make a quality test. So now that we have those two things marked up, what I want to do is go ahead, and the first thing that I should be doing when I'm looking at this, if I see values on my answer, notice A right here, it has numerical values. So what they're looking for, if you read this question, it says which portion can be used to show the slope of JL is equal to the slope of KL. So we're looking for the slope of JL and KL. Now notice they run on the same line. So that means our slope is going to be equal to one another. So I can say slope of triangle JNL is going to be equal to the slope of triangle KML. But notice they're putting numerical values in there. So we need to actually get the ordered pair for every one of our points and write them down. And we need to make sure that our total change in Y is on top and our total change in X is on bottom. And that's how they're setting up this proportion. One of these represents one triangle, one of them represents the other. And the easiest way to do this is to go straight to getting your ordered pairs for your two triangles and then determining which one has the Y values on top and the X on bottom. And so that way, therefore, the proportion is set up properly. So let's go ahead and take a look at how we're going to do this. So the best way to do, as I said, let's go ahead and write our triangle JNL. And we're going to put a J and an N and an L, and we want to find our ordered pairs for these points. Then we're going to do triangle KML. So K, M, and L. And once again, we're looking for our ordered pairs. Keep in mind that as we're looking for these, that we're trying to set up a proportion that represents the total change in Y. Remember, that's just our delta symbol. That means total change in Y over our total change in X. And we can write that out as we had written on our board on our anchor chart. total change in y over total change in x. And if we're looking for total change in y over total change in x, these values on top should all be y, and these values on bottom should all be x. If for some reason they put an x on top or a y on bottom, then we have an issue, and we can eliminate that possibility as an answer. So with that being said, let me go ahead and color code my two triangles so you remember what our points are. And I'm going to leave some colored pencils out for you in class whenever we have another test, and even anytime we're doing anything like this, so you can color code it, because I recommend putting color on it, and it'll help you keep from mixing up your numbers, because you could mix up your numbers and then you might not get the right proportion set up. So let's start with J and L. We can look at our value of J. It's right here. One thing that we can do, if you want, notice that there's no numbering on this axis. So if you want to, you can go ahead and label it. Like for instance, I could say, okay, here's -1. This point is -2. This is -3. This is -4. And out here is -5. And then I could say this is 1, 2, 3, 4, 5. Remember that to the right of origin, you're going to have positive values on x, and to the left of origin, you're going to have negative values counting down. So let's go ahead and we can label our y-axis too. We got 1, 2, 3, 4, 5. And here we have -1, -2, -3, -4, and -5. So if that helps you to label that axis with the numbers, then go ahead and label it. Nothing wrong with that. If you don't need to label it and you can just count, and it doesn't bother you, well, then you're fine then that way too. Do what's best for you. You know what you need to do. So I'm going to put me a little point right here on my origin. That's always 0, and that's always my starting point. So we're going to look at point J. So point J is 1, 2, 3. Notice that's right at -3. So I'm going to write a -3 for my x value, because here's my x's and here's my y's. That's how we write our ordered pairs. Then on my y value, I have 1, 2, 3. So that's going to be a +3. Then for n, it's over here. So I'm going to count over 1, 2, 3. So that's -3. Then my y value is 1, 2, 3. And it goes down, so it's actually -3. Then for L, I have 1, 2, 3, 4, 5. So it's at my 5. So I'm going to write that down. Then my y value is 1, 2, 3. So it's -3. Now we're going to move on to our small triangle, KML. So K is going to be over 1. So our x value is 1. And notice, we don't have to count up or down. It is actually lined up with the origin. So therefore, that value for y is going to be 0. Then we're going to do our point M. So we go over 1. And then we go down 1, 2, 3. So we have -3 for our y. Then for our L, we're going to go over 1, 2, 3, 4, 5. And for our y value, we have 1, 2, 3. And that's -3. So now we can set up our proportion because we have all of our points. We know what we're comparing. We're actually comparing the hypotenuse of JL. And it's saying that it's equal to the slope of KL, which is a true statement. So we're looking at this hypotenuse of the triangle, which is the longest portion of the triangle. And if you notice, they lie on each other, so they have the same slope. And that's why we can set up a proportion. And they're equal to one another, because they are proportional. Now let's go ahead. My next step, I would recommend you go ahead and make a little box around your y values. Because remember, we're going to be looking in our numerator and making sure that all our y values are the ones that are being used. If we see an x value in the numerator, we can already cancel that answer out. So let's take a look. So on answer number A, we have a -3. And what I'd recommend is think about your slope formula. For instance, our slope formula is m, which is our slope, is equal to y2 minus y1 over x2 minus x1. Remember, whenever we plug in a number for a variable, we're going to be putting it in parentheses. So what we have is parentheses minus some other number in parentheses over in parentheses minus another number in parentheses. So we should have a subtraction sign in between each one of our values. So if I put this in parentheses, that's negative 3 minus positive 3. Well, if you look, I have a negative 3 right here on my y. And see, those are all my y values that are boxed. And then I have a positive 3. So far, that one's good. Let's check the next one. We have negative 3 minus 0. So if we look down through here, we have a negative 3 again, and we have a 0. So that part's good. So at this point, I don't know that this is the right answer, but I know that everything on top is a y value. Therefore, it's very possible this is the correct answer. So before I check any further, I'm just going to look at the rest of these and see if I can cancel them out, because they may have some x values put in the numerator. So let's move it up. So here we go. Here's another one. We have negative 3, and we know that value is good, and it says minus 5. Now I'm going to stop right there because it shows a positive 5 in the numerator. Let's take a look right here. Do we have any 5s for y values? We have a negative 3, 0, negative 3, and a positive 3. There are no 5s. That 5 that they just put in here, look at that. That's an x value for L. With that being said, we know that it is impossible. We do not use an x value in our numerator because the numerator is only the total change in y. It's only y values being subtracted. So we can cancel out B. Let's look at C. Look at this. They use the same value. They have a 5 right here. They have a 5 just like that had a 5. Again, that is an x value, and because it's an x value, we can cancel it out. Now we can go to D. Once again, we see a value of negative 5. And not only is that is it a 5, but notice it's a negative 5. If you look on here, we don't even have a value of negative 5 at all. None of these points have a value of negative 5. There is nothing on negative 5 for the y-axis at all. So again, that's an indicator that is the wrong answer. Now at this point, you could go ahead and verify that our x values are matched up with the correct triangle, but since these three answers are wrong, I'd say you don't need to go any further. They're all wrong. A has to be the correct answer. It is the only one that has all of our y values, that has nothing but y values on top. So we'll stop there. A is the correct answer, and let's go to the next problem. Now, this one is a little bit different, but it is similar. Question number 2, it says triangle DEF, and once again, let's color code these. We got DEF. So if we do that, this looks like DEF to me. It's kind of hard to read those letters, and I know some of y'all said that, but I'm going to go with that and say that's my DEF. And triangles FMW. So now I have F, my M, and my W are similar right triangles. So now they're already telling us that they're similar right triangles. Notice that the hypotenuse, if we follow this hypotenuse, right, it merges right into the next hypotenuse. With that being said, and because they are similar right triangles, then we know that the slope of the hypotenuse on both triangles is exactly the same. Look, if we wanted to, we could even connect these two together and make one huge triangle. Do you see that? So, one thing we know from looking at these similar triangles with the hypotenuse that has the same slope, we know that the slope is equal. In other words, triangle DEF slope is equal to triangles FMW. So I'm going to put slope and slope. So we should just go into this question with that in mind. DEF, triangle DEF slope, is equal to triangles FMW slope. So with that being said, let's read all these statements and see if we can find one that's true. F says the slope of the hypotenuse of triangle DEF is less than the slope of the hypotenuse of triangle FMW. Well, we know that's not possible. They're similar triangles. The hypotenuses are merged together. We know that they have the same slope. But if we wanted to check that, we could actually find the slope of each and see if that's a true statement. So let's do that real quick. So I'm going to pull this over so we can see this. I'm going to go ahead and we're going to count our rise over run. So if I count my rise is going to be 1, 2, 3. So for triangle DEF, my rise is 3. My run is going to be 1, 2, 3, 4. So there's my slope right there. I counted. What I did is I counted from this point over to see how long it takes me to get over to it. So we just made a right triangle, right? We said our run is 1, 2, 3, 4. And our rise is 1, 2, 3. And that's how we got 3 over 4. This is my up and down for my triangle. This is my side to side for my triangle. Now that can't be further simplified. And so we're just going to leave it like that. Now let's look at this second triangle. If we count our run, or let's count our rise first. If we count our rise, we're going to go up 1, 2, 3, 4, 5, 6. Okay, so for triangle FMW, our rise is 6. And then our run is 1, 2, 3, 4, 5, 6, 7, 8. And it's 8. Now initially, if we look at these two numbers, we go, wow, look, the bigger triangle looks like it has a greater slope. But what you have to remember is when we're dealing with slope, we always have to simplify our fractions. So we can check to see if they're simplified. We can go ahead and put 3 over 4 for our first one, hit enter. Notice it stays the same. It is simplified to the utmost. Now let's go ahead and try our 6 over 8. So now we can put 6 over 8, hit enter. Look, it gives us 3/4. Those are equal. In other words, even though this value initially looks greater, it can be simplified into 3 over 4. And if we box that, we box this one, and we draw our line, they're exactly the same. Because they're exactly the same value, our slope is equal. So again, it's the same statement we made before. Now we already knew because they're similar triangles it was going to be equal. But this just absolutely proves that what we're saying and what we believe is true. And you can always do those calculations to confirm it. So when it says the slope of the hypotenuse of triangle DEF is less than the slope of the hypotenuse of triangle FMW, we know that this is absolutely false. Why? Because we just did the math. We counted the slope. It's exactly the same. So we can cancel that answer out. Now let's look at the next one. G says the slope of the hypotenuse of triangle DEF is greater than the slope of the hypotenuse of triangle FMW. Well, once again, it's saying it's greater. Well, if it's not right, if it's equal to one another, it can't be greater. So again, that's false. Because looking back at what we did, there's neither one of them is greater. They're exactly the same once simplified. Cross that off. H says the slope of the hypotenuse of triangles DEF is equal. Now there's a key word. That's what we've been saying all along, is that it's equal to the slope of the hypotenuse of triangle FMW. That is a true statement. So we know it's the correct answer. But just to look and see what the last one says, let's see, it says the relationship between the slope of the hypotenuse of triangle DEF and the slope of the hypotenuse of triangle FMW cannot be determined. Well, that's not true. So we know that's invalid, because if it couldn't be determined, we wouldn't have been able to get a value that represents slope, right? So now you know the correct answer. Go ahead and make sure if you missed this question to mark it down on your sheet, what you missed, the question number, why you missed it. Did you miscalculate slope, or did you not simplify one of the slopes? Mark whatever made you miss it, and then mark how you fixed it. And let's go on to question number 3. Alright, in this question number 3, it says, Minnie read a book at a constant rate. The graph of her progress is shown. So notice it has our graph, and this one is pretty clear. It says, which statement best describes the situation? The slope of the line, let me scoot this back down, is different, I'm going to underline that, from the unit rate of 2 over 3 pages per minute. So it says the slope of the line is different. Well, let's see if that's true. It's saying the unit rate is 2/3 page a minute. So let's see. So what that means is we read 2 pages, and then our time is on the bottom in minutes, in 3 minutes. So I'm going to put a point right here. So over 2, up 2, and then over 3. And if you notice, right, when we're counting our rise over run, we have the rise over run. Well, let's face it. The rise is up 2, 1, 2. And the run is 3, so it's over 3, 1, 2, 3. And that is our slope. So that's a false statement. The slope is not different from the unit rate. We derive the unit rate from the slope. So this is a false statement. The next one says the slope of the line is different from the unit rate of 1/2 page per minute. We could look at that in one way. We could say, well, yeah, it is different because the slope is actually 2 over 3. But the problem with this is our unit rate, it says, is 1/2 page per minute. Well, is that even a true statement? Is the unit rate really 1/2 page per minute? Because we just checked it and it looked like 2/3. So let's take a look at it. That would mean we'd read 1 page in 2 minutes. And let's see if that's true. Here's one page, and there's 2 minutes. Now notice, look at that line. It doesn't even cross through that area. It crosses a little bit above it, but since it doesn't contact that intersection, so where 1 page in 2 minutes is, that part is absolutely false. And since this statement right here is false, then it cannot best describe the situation because it should be accurate. So let's cross that out. The next one says the slope of the line is the same as the unit rate of 2/3 page per minute. Well, we said our unit rate is 2/3 page for every 1 minute. So let's take a look at this. Well, do we read 2 pages in 3 minutes? So you should ask yourself, is that a true statement or not? Then that would mean that we read 2/3 pages a minute. And that would be our unit rate. 2/3 pages per minute. With that being said, this is a true statement because it says the slope of the line is the same as the unit rate of 2/3 pages per minute. Well, it is true, right? Because our slope is going to be 2/3. And then if we turn it into a unit rate, it's 2/3 pages per minute. So this is our pages, and this is our time. So this is actually a true statement. So C right now, that's a good answer. But question number 4. It says the graph below shows the number of coffees served per hour at a local coffee shop. Based on the information in the graph, what is the slope of the line? So what we want to find here is we want to find the slope of our line. Now remember, when we're finding a slope, it's just like our last problem. We're going to be looking for rise, which is our up and down, over our run, which is our side to side. One thing that I like that I saw on a lot of y'all's tests that you did is some of you knew that you had trouble seeing these lines. And what you did is you got the protractor, and some of you didn't use a protractor, but a lot of you did, and you actually traced your lines so that you could count better. And I just think that was a really smart idea for those of you who did that. Those of you, if you didn't think about that, next time I'm going to have protractors out. I would always say use a protractor if you need to straighten it up to make sure that you can get your best answer. But that was just a good way to kind of eliminate any confusion. And you didn't have to put the lines across this whole thing. You just need it where you can see your line so you can count your data properly. I'll stop right there. So that kind of makes it a little bit more clear where my lines are. And I'm going to go ahead and draw me some coming across. Feel free to do this if you run into this again. That way you can try to make sure you get the best answer possible. I'm going to do this because even for me, it's just so easy to make a mistake if you can't see the line clearly. There we go. And that's enough for us to get a pretty good idea of where it's crossing. So it says, based on the information in the graph, what is the slope of the line? So we want to know the slope of the line. and it gives us some answer choices. So what I would say is, as we're looking at the slope, we can go through here and see which one best represents it. So it's saying 18 coffees per hour. Now remember, when we're dealing with unit rate, it is always the slope over 1. The other one we had dealt with a fraction. It said 2/3, remember, when it's talking about the pages per minute, and that's why I did 2/3 over 1. But since this says 18 coffees per hour, we're looking for a slope that's 18 over 1. And if we're doing 24 coffees per hour, we're looking at a unit rate of 24 over 1. 32 coffees an hour, we're looking for a slope of 32 over 1. And with our unit rate of 28 coffees per hour, we're looking for a slope of 28 over 1. So there's some pretty big differences on some of these. So let's see which one of these slopes, right, that match our unit rate when we're looking at this. So let's see. So we're looking at this. I'm going to go ahead and draw this over. Now notice this says 1. Do y'all see that? So if this is supposed to be 18 over 1, we have to make sure that that line comes all the way over to 1. And notice right here is 1. We need it to be, in order for this to be a true statement, we would need this value to be 1. But notice this value isn't. Where I put this point on this line, if we follow it down, to me, that looks like we're close to 1. So 1, 2, 3. So that's, it's somewhere close to 1, but it's not 1. Do you see that? It comes down right here. That is less than 1. So since it's not 18 over 1, it's wrong. This is actually 18.1 right here. So we know F is definitely not the correct answer. Now let's do 24. So we have 24 over 1. So let's see. I'm going to start with my X. I'm just going to follow up my X line. And I'm going to stop at 24. And here's 24 right here. So here's my next point. Now look, it's closer than the other one. It's closer than the 18. We're headed the right direction. But that line doesn't cross my 1. So when 24 is right here, it doesn't cross the value 1. So it is not 24 over 1. We can cancel that out. The next thing we can do is look at the next. It says 32 coffees per hour. Well, let's see. If we follow our 1 all the way up to 32, and I'm just going to use this to stop at 32. That's 32. It hits right here. Now if I draw a dot there, now look at that. That definitely looks like a possibility, because it crosses right there. So I'm going to say, you know what, 32 is definitely a possibility. I still want to look at my 28, but I think it's definitely a possibility. Let's take a look over here at 28. And if we start from 1 and we go up to 28, that looks like a possibility as well. So it's definitely going to either be 32 or 28. And just looking at it where my dot is, I think the line crosses better through 28 than 32. Now I do notice I got a little bit bigger gap right here, so I think this line probably is a little bit more to the left. If you notice that this, even though it looks like it crosses closely, it doesn't cross close enough. This one is even more close. So I'm going to go with this answer. I'm going to say 28 is my best option. And again, this is one of those ones where having a clear graph really makes a big difference. But once you put your points on here, you got to really say, okay, which one is the closest? Alright, so now we're going to go ahead and go to our next question. I know in the test, for some reason, they put question number 6 before question number 5. So I'm doing it the order that's in the test, because you have your test booklets. And I'm sure they're going to make sure that they get that corrected next time around, because 5 does come before 6. What we're going to do is, on this one it says, on a field trip, there are 3 adults. So anytime we get information like that, let's box it. For every 45 students. Which graph models a relationship with the same unit rate? Well, if there's 3 adults for every 45 students, we want to make sure that we're looking at our rise and run. We have to look at our 2 graphs and see which one of these looks like it could represent adults and which one looks like it could represent students. So what I would like for you to think is think that when we have 3 adults, our values are going to be less on our axis, and when we have 45 students, our values are going to be greater on our axis. So which one of these axes has the lesser values? So this one only goes to 10, right? And this one goes all the way to 150. Well, if we have 3 adults for every 45 students, then we need a really big number for our students. So this one's going to be our students. It has to be. And this one that's lesser value, right? Only 3 adults for every 45 students. Well, this has got to be our adults. That's the first part to figuring out this type of a problem. If they don't label the access, it does make it more difficult. But you just have to think it through and think which set of numbers is more meaningful. So in other words, if we had 3 adults down here, we would only be able to count 10 students. Well, since we know we got to be able to count at least 45 for 3 adults, if we labeled this students, it wouldn't make any sense. So we got to make sense of the data. Now we're trying to find a relationship where we have 3 adults to 45 students. So the next thing we should do is look at how are these, what are the increments on my units when I'm going up and down. Well, notice this goes from 1 to 2, 2 to 3, 3 to 4. So this is counting by ones. Then on the bottom, notice it jumps to 30 really quick after this first line. And once again, if I were to draw this, just so you can see it a little bit better. And I think that'll be enough. I'm only going to draw it on this first one because I really want you to be able to see what I'm talking about. Okay, so you can see our lines here. Now, this first line right here, notice it's in between 0 and 30, and it's one line. Therefore, it's half of 30. So if we said, okay, well, I'm not sure what half of 30 is, we could go over here and we could say, well, 30 divided by 2, that cuts it in half, and that gives me 15. That tells me that this value is 15. Now, if it goes from 0 to the first line and it's 15, that means we're counting by 15s. So we go 0 to 15, and then 15 plus 15 is 30. And then if we add another 15 to 30, that means this line is 45. This is important because the two numbers we are working with are 3 and 45. And what we should see is a graph that meets each other and comes through these points. In other words, in this one, my graph should be going through here. Obviously, it's not, right? So we can say, well, F is definitely not the correct answer. So now let's go over to the next one, and let's see, does 3 match up with 45, which is the number in between? And I'm just going to mark those two. They should match up with each other if I draw a line across. So I'm going to come across. I'm going to come across. Notice those lines converge and meet at that point. With that being said, this is my 45, this is my 3. So that tells me my rise is 3 and my run is 45. And this graph matches it perfectly. So therefore, H would be the correct answer. Now let's look at G and J, just so we can say, well, let's eliminate it in case one of you chose one of those, and let me show you why it's wrong. So let's see, so if this one, it matches up with 3, and here's 45. So if I go up on the 45 and I go over on the 3, my line should be going through that point. So we can see this one is actually wrong because it doesn't have enough students. So we can say G's wrong. If we go to J, well, let's see, if we go at 3 and we go at 45, once again, we should have a line going through here. Now notice this is running horizontal, right? Our slope of a horizontal line is equal to 0. Well, we got a slope. Our slope is 3 over 45. And if you notice, this one's 0, so this is not equal, right? It's not equal to 0. So we can say, well, J, we can eliminate that again because it's impossible. Where slope, we have a value, it cannot be 0. And let's go to the next question. Alright, on question number 5. It says a tree in Dante's neighborhood grew 18 inches in the first 2 years after it was planted. So that sounds like important information. It grew 18 inches in the first 2 years. And so when we see that, right, we're thinking about distance over time. So you know that's what goes through my head. I got distance over time, and then that makes me think about a unit rate, right? Because we have quantity over time. So when we think about quantity over time, right, and we have 18 over 2. So now we just need to look and see, well, does that match our data? So notice that our time's on our x-axis, and the growth, right, the distance it's growing, is going to be our y-axis. So that is our slope. So we can go ahead and rewrite that and say, yeah, okay, we get this. This is our rise over our run. This is our quantity over our time. So with that being said, let's see which one has a slope of 18 over 2. So if we go here, here's my 18. I'm going to come over, and here's my 2. I'm going to follow my 2 up, my 18 up. There's my point. So my line should be running through here. But look, it's not. Actually, if we look at this tree is growing a lot faster. After 2 years on this one, it's actually grown somewhere close to 45 inches. So that's a lot. So we go, well, no, that tree's growing way too fast. So now let's look at the next one. So on this one, right, if we go, okay, well, 18 inches comes over, and we have 2. And if we look, try to make sense of this data, well, it does cross at 2 and 18, but let's think about what this means. If it goes straight up, what do we call that slope? And if you remember, a line that runs vertically has an undefined slope. Okay, so just to put this in perspective, this is saying that in 2 years, our tree grows an amount that goes on forever. So this is like Jack and the Beanstalk, right? This tree grows up into the heavens and outer space. So we know that's not even possible, first of all. And it doesn't match our data, because we say that it definitely grows 18 inches in the first 2 years. So we say, well, this is impossible. And it definitely doesn't grow 18 inches in 2 years. In 2 years, it grows to an infinite height that goes on forever. So now let's go ahead and go to B. When we're looking at B, the tree growth, okay, so here's our 18. Let's go over to 2, and this one's our 2. Now look, that does cross through that point. 18 inches in a period of 2 years. So B is definitely going to be a possible answer. The reason I say possible is because since I can't see these lines in this graph good, and I know neither could you, I want to make sure that this graph over here doesn't even make it look like it's more clearly cut. So let's take a look at this one before we circle this answer. And we should always do that. Look at all your answers before you decide, because there always might be one that's a little bit better. Okay, so here's 18 inches, and here's 2 years, 18 inches. And let's see if they meet together. Okay, so no, it doesn't. Look, our graph should be going through there. So if we take a look at this graph, it's growing much more rapidly than what we have. So D is not the correct answer. So the best answer choice, even if you weren't able to see any of these lines in here, the best answer choice is B. And that's the correct answer. Right, in question number 7, I did notice that about half of us missed this. So this is something that we really need to make sure that we focus on. And so let's take a look at it. I know the graph is small, and I think that did have an effect on you missing it because it's hard to read the numbers as well. I can't really make many of them out. But let's take a look at this, and I'm going to show you a couple of different ways we could have done this. First of all, when we have a graph that we have a hard time reading, but they give us an ordered pair, what we should have done is revert it back to that slope formula. So remember, we could have used, to find our slope, we could have said, well, let's do y2 minus y1 over x2 minus x1. And I want you to think, anytime you run into a graph that you have trouble reading, to be able to count the slope, and because I know a lot of you looking at your papers, you tried to do it looking at rise over run. You made your triangle, and that was a great idea to do. It's just that this graph it's so difficult to see where it's actually running through that you would have done better if you would have used your slope formula. But let's go ahead and let's try to make sense of this. I'm going to use this slope formula and plug in my numbers. So I'm going to call this one my this is my x2 and my y2, and I'm going to call this one my x1 and my y1. So let me plug in my numbers. So let's see, we have y2 minus y1 over x2 minus x1. So my y2 is negative 2. I can clearly see that. And my y1 is 0. And then my x2 is positive 2. And my x1 is negative 6. So if I put this in my calculator, And what I would do is I recommend that you put this in your calculator. By the way, I did want to say that quite a few of the students who got this one right, I know they were having trouble with the graph because they resorted to using the formula and instead of counting the rise over run. So that was a very good, for those of you who did that, good thinking. When you see something that's hard to differentiate and you jump to using an equation, I think that's a great idea. So let's go ahead and put this in. So we have -2, and then we're going to do minus, oh, let me go back, -2 minus 0, and we're going to go down, put our parenthesis, and then we have 2 minus -6, and then we hit enter, and that gives us a value of -1/4. So just with knowing the slope, right, we have -1/4, we can look at these numbers and we can automatically eliminate two answers. So for instance, we can eliminate A because it's definitely not 4, it's 1/4, and we can eliminate B. So now we have a 50% shot of getting it right, because both of them are 1/4. So the next thing that we can do at this point is look and let's see. Notice that it has a negative sign, right? We had -1/4. And we can see clearly that this slope runs negative, right? It runs downhill. If we're running downhill, it's always negative. Well, let's look at these two values. This is -1/4, and this is +1/4. So with that being said, we can eliminate this slope because it's positive. This slope is saying that it's running uphill, so that's wrong. So without even looking at the y-intercept, even if we couldn't read this number to determine what the y-intercept is, by the slope alone, we could have guaranteed we got the right answer. And even if we can't read the lines and the numbers to be able to count the rise over run, we can depend on this formula that's given. And this is on your STAAR test prep. If you notice, whenever you get your STAAR formulas, it has this slope formula on it. Now, if we wanted to look at this, I'm just looking at this point, and that looks like I'm thinking this is a 1 right here. And I'm thinking that's 2 right there, and it looks like it's about in between the 1 and 2. Let me let this refocus real quick so you can see where it goes. And it looks like this is in between the 1 and 2. And so with this being in between the 1 and 2, I would agree that that's about 1/2. And notice it is below the y-axis, and we have this -1/2 y-intercept. So in this graph, I can just tell you, me looking at it, I wouldn't have been able to determine that it's -1/2 on the y-intercept, but I would have been able to find my slope using the slope formula and get the correct answer. So just keep that in mind. It's another tool you have in your bag other than counting the rise over run. Alright, now on to question number 8. It says the graph shows the depth of the water in a fountain over several days. Which of these best describes the depth of the water of the fountain? So what we're going to be looking at, this one does have a clear graph, so we're good on that. We can count this real easily. So let's go ahead. I'm going to move this up just a little bit so we can look at our answer options. And notice it says which of these best describes the depth of the water of the fountain. The first one says the amount of water in the fountain decreases by 3 centimeters each day. Okay, so if it decreases by 3 centimeters each day, so that means we have 3 centimeters that it changes over our time, which is 1 day, and that gives me my slope. Now if it's decreasing, right, then we got to say it's negative because it should be going down, and this confirms that we have a negative slope. It's going down, so it's decreasing by -3/1. So let's see if we can make sense of that, if we can actually find that on here. And this one I would use that rise over run method to count. So okay, so here's 24 right here, right? So if you notice, in 1 day, and this says 1 day right here, in 1 day we decreased by 3 because we went from 24 to 21. Notice it lines up with 21, so we went from 24 to 21 in 1 day. On 2 days, if we looked at it, it went from 21 to 18. That's also a decrease of 3. So we can look at it and go, okay, this is a true statement. It really does decrease 3 centimeters each day. So what I'd say is let's underline it, because that's definitely a correct answer, but we want to make sure, since it's saying best describes, that there's not one that describes it better. So let's look at the next one. It says the amount of water in the fountain decreases 1 centimeter each day. Well, that's not true. we just confirmed looking up here that it's actually decreasing by 3. If it only decreased 1, if I were to go up on this one right here, right, if it only decreased 1, then my line should have crossed through about right here, and my line doesn't cross right there at 1. That means my point would be right here. It crosses lower, so we say, okay, that's definitely false. We can scratch G out. The next says the amount of water in the fountain increases 3 centimeters each day. Well, if it was increasing each day, our graph would be going up. It'd have a positive slope because increase is positive. So we can say, okay, well, H is definitely wrong because that's not even a true statement because it would be positive. And J says the amount of water in the fountain increases 1 centimeter each day. Well, again, we can cancel that out because it's saying it's going to increase. And we can look at our graph and clearly agree that it is decreasing each day, all the way into the 8th day where it has 0. So there is no depth. All the water has been drained out of the water fountain. So the best answer is F. Thing I wanted to add is that the majority of you a lot of you got this answer correct, and I think it just goes to show because of this clear graph you're able to interpret the data really easily. So great job. Let's move on to number 9. Alright, this is another one that I think quite a few of us did pretty well on. We had to do some critical thinking. It says Carolyn will buy the same number of stamps every month to add to a stamp collection her grandfather gave her. So let's keep that in mind. Her grandfather gave her a stamp collection. And the table shows the number of stamps Carolyn will have at the end of X months. So now it gives us this table here. Now what I've seen a lot of you do that was really good is a lot of you started right off the bat looking at your rate of change. And I like that because that's a sensible thing to do. So what we can do is say from 1 to 3 months, right? We had a period of 2 months that changed. We increased by 100 stamps. Then we had 3 to 6 months. We had a period of 3 months and we increased 150 stamps. And then from 6 to 10 we had a period of 4 months and we increased by 200 stamps. Now notice they kind of tricked us on this one because they're not changing. If it would have said 1 month, 2 month, 3 month, 4 month, it would have been real easy to get the slope. But they changed it on us so that you didn't see this constant rate of change. But if we go ahead and check for the second month, it makes sense. So let's go ahead and put this in, right? Let's say 100 over 2. What we're going to do is look and see. The same way we check to see if this is proportional, we can use that to kind of try to determine. But we're going to be using basically a ratio to determine our slope and see if we have the same slope all the way across. So what I did on mine, I just said, okay, well we got 2 over 100. So let me do that. My change in y was 100. So I'm going to do my fraction bar. I'm going to do 100. And then my change in x was 2 months. And that gave me 50. So I had a change of 50. Well, let's check this next one. I have 150 over 3. So more time has passed, but if I do 150 and I do that over 3, look what it gives me, a 50. So now I'm going to check this next one, right? We have 200 over 4. Still gives me 50. So that tells me my slope is 50. So this one has a slope that's equal to 50, right? That's my rate of change. With that being said, I know that every month she increases by 50 stamps. So I'm going to stop there once I got that slope. I liked what y'all did. And I'm going to read the questions and see which one makes more sense. Because it says, how many stamps was Carolyn given? And how many stamps will she buy? So it says, Carolyn was given 200 stamps. And she will buy 50 stamps every month. Okay, well 50 is a good number. We already figured out that our rate of change is 50 stamps. I guess we could write it this way, right? Our slope is 50 over 1. 50 stamps per month. Well, it's saying 50 stamps every month. That's 50 stamps per month. So A is definitely going to be a possible answer. I haven't looked at the first part yet. We're going to figure that out in a second. I just want to see, can I cancel out some of these by knowing how many stamps she gets a month. And if I look at the next one, if I look at D says 70, or I'm sorry, B says 70 stamps a month. Well, I know that's false. She's increasing by 50 stamps every month. So we can just cancel that out. Carolyn was given 180 stamps and she will buy 50 stamps every month. There's that number again, 50. We know that's relevant. That's our slope and it's our rate of change if we make it per month. So C is a possible answer. And D says 70. So we can go ahead and rule out D. Now, just by knowing what our slope was and converting it to a rate of change, we are able to eliminate two answers, and there's only two possible choices. So let's see which one makes the most sense. If we know that she's buying 50 stamps a month, and this is where that critical thinking comes in, what did she start with? Notice it says she has 250 stamps after 1 month. But what did she have when she was first given it? That's 0 months. So when it was first given to her at 0 months, before she bought that 50, how many did she have? Okay, so what we can do is say, well, at 0 months she had some number. And we know she now has 250, so I'm going to write that. Let's see, let me write that over here. She has 250 right now. She gets 50 a month. So at 1 month she had 250. Well, let me take that 50 back off so I can figure out where we started at 0. So if I do minus 50, because I'm looking for the 0 month, I'm going to write it over here. At month 0, alright, this is my X, and this is my Y. We had some value. So 250 minus 50 gives me 200. So that means at month 0, before she bought any, she had 200. After her first month, she bought 50, so then she had this 200 plus the 50 she bought, and that gave her 250. So do you see how this makes sense? This 0 and 200, you can add on to it. So you could have just counted back. You could have said, okay, well, I'm going to decrease by 1 month, and that'll give me 0. And then I know she buys 50 a month, so I'm going to decrease by 50, and that gives me 200. That's another way you could have done it, but I just do it this way because to me, in my mind, it just makes more sense. But you do it the way that makes more sense to you. So at 0 months, she had been given 200 stamps. Well, this one says 200, so this is definitely the correct answer. If we go down here, notice it says 180. So in order for that 180, then that would mean that would just be incorrect because it's 20 stamps off. And if she only got 50 stamps a month, that means on month 1 she would have had 230 instead of 250. So we can say, okay, we can rule that out. So that's just a way you think through this by using the information that you're given. So let's go ahead and go to our next question. Let's go to question number 10. Now I noticed on question number 10, I had a lot of us struggled. A lot of us made some mistakes, and it was just a table. And I'm wondering if it's because of this word function. You've seen function. But we did talk briefly about it, and we're going to get into functions this week, and you're going to better understand what functions are. But notice it said the word linear in front of it. And remember we had that talk about anytime if you run into a word that you're not familiar with, or that even if you forgot it, try to find a word in it that you can recognize. And in linear, I recognize the word line. So that just, I'm thinking, when I see linear, I'm thinking, okay, it's going to be a graph that has a straight line. That's what comes to my mind. So with that being said, I'm looking for something that has a straight line. And then it says, what is the slope of a line that is represented by the values in the table above? So even if there was any confusion about this function, we should have been able to look down here and say, okay, well, we're looking for slope, and we know what slope is. So how do we find the slope out of a table? Well, one of the easiest ways to do it is for us to look at the change in x and the change in y. Now remember, you could have used your slope formula and pulled two sets of points out, or you could have just used the table and found that change in x and a change in y. We're going to do it both ways, and I'll show you how both ways could have worked. So our change from -5 to -3. And if you're not sure about the change that occurred, you could always put it in your calculator and subtract it. You could say, okay, -3. And then you could say minus -5. Hit enter. And look, it gives us a +2. Okay, so our change from -5 to -3 was a +2. From -3 to -1. Okay, so we can put that in our calculator again. -1 minus -3. And again, it gave us a change of 2. And this is linear, so it should be no surprise that we have this same value repeating itself. From -1 to 1, well, that's also a change of 2. From 1 to 3, that's also a change of 2. Now we need to look at our change in y. Well, what's 3 minus 0? And 3 minus 0 is 3. Because we went from 0 to 3. Then we went to 6. So 6 minus 3 is 3. 9 minus 6 is 3. 12 minus 9 is 3. Well, they told us that it was linear, so it's no surprise that we have this constant rate of change, because all linear equations are going to have a constant rate of change. And what we have is a 2 and a 3. Now remember, when we do our slope is always rise over run. Or we could say our up and down over our side to side. And then I'm also going to put rise over run. So my rise, right, is going to be my 3. You see that? This is my y value. That's my y. And my run is going to be 2. Now, even though this has some negative signs before it, and that might have been something else that got y'all mixed up, you might have wanted to put a negative slope because you've seen a negative sign, but our rate of change was actually positive. So it is a positive 3 over 2. So let's see which one of these answers is 3 over 2, and the best answer is J. Now, I want to show you another method that we could have done to derive the same answer. So the other thing that we could have done is we could have said, wow, this looks confusing. I have some negative signs in here. Maybe I'll make a mistake in my calculation. Let me just choose 2 of these points. And if I were you, if they give me this many different points, I would choose the positive ones, because I think they're just easier to work with. You don't have to worry about putting in a negative sign on your calculator. You only have to use your minus. So remember our formula. When we look for slope, y is equal to y2 minus y1 over x2 minus x1. So now I'm going to plug in my numbers. So I'm going to have my y2 minus my y1 over my x2. Oh, I shouldn't write x2. Let me put parentheses because we're going to plug in a number. Minus x1. So now we just got to label them. I'm going to call this my y2. And I'll call this one my y1. This would be my x2. And this would be my x1. So with that being said, now notice my x2 and my y2, they're both put together, right? And my x1 and y1 are put together. If I wanted to write this as an ordered pair, in case some of you are going, well, hey, why are you writing y2 over here and x2 over here? Let me show you what I did. I said 12 and 3 are one ordered pair, so it's 3 and 12. And then I said 9 and 1, those are going to be another ordered pair. Remember, we put our x's first, we have x first and our y second. So then I could say, okay, 1 and 9. So this is my second one, so I'm going to do my 12 is my y2, and my 3 is my x2, and then I have my 1 is my x1, and my 9 is my y1. With that being said, we just need to plug in these numbers. So my y2 is 12, so I'm going to plug in my 12. My y1 is 9, I'll plug in my 9. My x2 is 3, so put that in there, and my x1 is 1. Now you could do this by hand. You don't have to use your calculator, but I think with the calculator it'll make sure that you don't make any errors. And so if you want to use it, you're more than welcome to. You can use it. So let's put our parentheses. We have 12 minus 9. 12 minus 9 over 3 minus 1. And we have 3 minus 1. Hit enter. And it gives us 3 over 2. So that's equal to 3 over 2. In this case, me personally, it's just because I'm so familiar with the formula. I feel like the formula is a lot of the time it's just quicker and easier. But if you like counting the table, you're welcome to do it that way. Use the way that you feel is the best way. And if you're not sure you got the right answer, if you have any doubt at all, there's nothing wrong with doing it both ways to check your answer. And I would, if you can remember this formula, and even if you don't remember it, if you can just remember to look at your STAAR formula chart and see this slope formula, I would go ahead and check it both ways just to make sure that you didn't make an error either way, and that'll make sure and guarantee that you get that answer right, and it is positive 3 over 2. So this is the end. Finish all your corrections, make sure you have that filled out and turn it in so that I can go ahead and make your test correction and bump your grade.